So sometimes it's helpful to just think about the principles we're going to use when we're working on the design of displays. One of the first ones, and sort of most obvious, is to make these displays legible. Or if these displays are auditory displays, things like warnings and so forth, they should be audible. You ought to be able to hear them. So in terms of visibility, of course, the characteristics of visibility include things like high contrast and reasonable size. And in the next lecture, we'll end up talking about some of the characteristics of audition, but specifically they should be loud enough, the tone could be heard. You should avoid excessive masking, that is, you should be able to distinguish the sounds from whatever's in the background, the ambient noise. So this is the idea of the first perceptual principle, which is a bottom-up principle, right? Which is making displays legible or audible. Another one is to avoid absolute judgment limits. What I mean by that is never require the user to judge the level of one variable, like color or size or loudness, that contains more than 5 possible levels. People just are not good at discriminating lots of different levels of the same color, for example. So you could see a couple of those. For example, 5 different colors with different meanings. People don't do a very good job at this. Not only that, about 9% or so of males are colorblind. So they have a difficulty discriminating either between red or green or yellow and blue. And they have, those things end up getting washed out and looking a lot like gray. So don't require just one sort of variable like color or size or something like that. Don't let that have meaning. Instead, include that with something else like a label or a number or something else that indicates the meaning of that particular indicator. Otherwise, it's really hard for people to do things like discriminate and remember, oh, what's the meaning of brown versus what's the meaning of blue versus what's the meaning of turquoise, for example, down here. Here's another one, and I think this is critical, is the notion of redundancy. So note, for example, this stop sign here. You can tell that's a stop sign in a lot of ways. Not only does it say stop on it, which makes great sense, but you can tell from the shape, it's octagonal, right? And you can tell from the color because it's red and it's white. And you can tell from the border because it has a white border around it. And it typically shows up in certain places. So for example, most often it's on a corner somewhere, though it could be other places too. It has a standard height, that is, it's supposed to be a certain height above the ground and so forth. So these are both examples where you're using 2 types of sort of coding, in this case shape as well as color, in fact more than 2 here, as well as words, etc., to all mean the same thing. So this is saying the same thing in several different ways, which enable people to become very good at making decisions about these things. That's particularly useful when, for example, you're in non-ideal conditions. For example, maybe there are tree branches hanging down in front of this. Maybe you're looking at it from far away. Those kinds of non-ideal degraded conditions. Oops, I went backwards. Here's another one, the ability to discriminate between displays. Similarity often can cause confusion. So what I mean by that is items that look similar to each other are often mistaken for each other. And you can see that here. Imagine how difficult it is here to be able to determine that this guy, that display there, is different than, say, that guy. They end up, looking awfully similar to each other, which is probably a cheap way to do things. You probably get these dials in, or these gauges in bulk. But on the other hand, it makes it very, very difficult to discriminate one thing from the other. Another display is related to sort of mental models, how people think, how people remember, how they organize knowledge about the world. And that is called pictorial realism. The principle is that a display should look like the variable it represents. So ideally, it would be a picture of it. For example, a thermometer which has highs or lows should be vertical, Altitude display should be vertical, all of those kinds of things. These are signs and displays that really do look like the thing that they're representing. Here's the sky, here's the ground, here's the horizon. It really does look like that thing that is the information that it's representing. That's called pictorial realism. Another is the principle of the moving part. That is, the moving element of a display should move in the direction that's sort of compatible with the user's model, compatible with their expectations or their mental model. So for example, to go up, this is a vertical speed indicator in a plane. Going up, that actually means that this dial goes up. Going down in altitude, that means that this dial goes down. Same thing even for things like turning on light and off light switches. Another mental model principle is to minimize information access cost. And what we mean by that is it takes time and effort to move attention from one display, especially one location, to another. So that time, information in your working memory during that time tends to degrade. It's hard to hold something in working memory that long going between one display, finding the other display that you're looking for, looking and seeing what the information is on the other display, and somehow remembering the previous display. Putting those two together ends up taking a lot of time and a lot of effort. That's even true when you're looking at the same computer screen, just traversing menus, you run into exactly the same problem. It also reduces the opportunity for comparison. So if you don't have two things side by side, it's really hard to compare them. So that's what I mean by minimizing information access costs. Moving from one place to another, even just your attention, even just your eyes, tends to have a cost associated with it in terms of cognitive resources. Another important mental model principle is the principle of proximity compatibility. And all that means simply is that related pieces of information, like if they belong and are used in the same task, they should be placed close to each other. Here's kind of a bad example of this. This did not do well when it first came out. This is BMW's iDrive. And down here, they do have an improved version, thankfully. But down here, he's controlling something. He's actually using a control down here and looking at the results up here. And this can be problematic simply because the distance between here and here, as well as it is quite far. In addition, they're on different planes. So this is on a horizontal plane, whereas this is on a vertical plane, and that mapping isn't always completely obvious. And sure enough, that caused problems. There were many other problems with this particular product. One was just the information architecture. People had to go through lots and lots of menus, and as a result, the information cost was really high. But what you're trying to do is place items that are related to each other in the user's mind. You want to take those and place those together in the user interface as well. Just like with redundancy that we talked about before, redundant coding, for example, sometimes it's helpful to present information concurrently at the same time, basically, across more than one sensory modality. And here's an example of how this is done with fire trucks. So clearly this is an emergency situation, you can hear it, you can see it, etc. And that way, hopefully no one modality, either vision or audition, is overloaded. It's sort of telling you the same message in two different ways. And previously, in the previous recording, I mentioned something about predictive displays, which we'll cover here in a minute. But one principle is replacing memory in the head with knowledge in the world. And what I mean by that is a lot of what we do, getting through our day-to-day lives, we are looking for cues in the outside world. So for example, when you see a door like this, and you see that handle, you know that you're supposed to pull on it. And similarly, when you see a plate like this and a door, you know that you're supposed to push on it. Those kinds of things don't even require labels. People tend to know right off the bat that that's for pulling, that's for pushing, and as a result, they don't have to remember that when I get to the door on this side, I'm going to pull it because that cue is right there. Sometimes we call that an affordance. And that's largely what you're trying to do, is make it so that people don't have to carry so much information around in their head, and instead that information is provided through kind of obvious cues in the world. Here's another example of that. This is giving people an idea of where they're going to go. So this, they don't have to realize, they don't have to remember exact directions. It's provided for them right in front of them. They've taken that knowledge that a person might have to carry around in their head, and they've put it out in the world, in this case in a navigation display. And speaking of navigation displays, one of the important things to do is to be able to provide some kind of predictive aiding. Tell people, basically help them anticipate what they're going to do next, where they're going, help them prepare for what's coming next, what lane they ought to be in, all of those kinds of things. A great example of these, of course, are navigation displays. And I talked a little bit previously in the previous video about situation awareness displays. A navigation display is a good example of that kind of situation awareness display. It's telling you where you are right now, and it's telling you what's coming up next. And as a result, you can have a pretty good idea of predicting the future and what you ought to be doing. And that's really what situation awareness is. It's an understanding of what's going on now, and being able to forecast that a bit into the future. Another memory principle is simply the principle of consistency. Do the same thing the same way throughout your system that you're designing. This, of course, is a terrible example of consistency, or a good example of bad consistency. We've all wrestled with lots and lots of different kinds of remote controls, and largely, one of the reasons we wrestle with these is they're just so darn inconsistent among each other. And finally, I talked a little bit previously, but I'll mention it one more time, about monitoring displays and things like speedometers and so forth. Analog displays, things like this, tend to be best for reading at a short glance and estimating how much you're changing, for example, how fast you're accelerating and so forth. Digital displays, for example this down here, tends to be better for more precise readings. In this particular case, this automobile decided to provide both. You don't have to provide both, but it is the idea. You have to think about, what is the information I'm trying to convey? Am I trying to provide something that's really precise? Or am I simply trying to give people a general idea of what the reading is?